All right, everyone, we are back. Okay, the next part of our training today would be the complex tracking motion learning. Okay, to operating the robot to complete complex tracking motion, getting familiar with the use of robotic motion instructions and the Cobot's drag and drop teaching functions, learning the mobilization of the track recorded in script, as well as the use of CR user and Tor coordinates. Those are the objects we are going to learn in this part. So in this part, there will be 3 tests. First one will be complete track motion through motion command. And second, complete track motion through drag and drop teaching. Third one will be the use of user and Tor coordinates. Okay, so here you can see we have 3 different trajectory in here. We have this I don't know how to say it. It's a rectangle, I think. Rectangle. This is the first one with 4 straight lines, and the second would be a triangle. So those are the 2 different simple ways we can do just with go P5 and then prepare a point, then move to P1, and then move P2, P3, P4, and then move back to P1. So with this move, do you remember that the move is a straight line from A to B is a straight line for move. This is a move command. Okay, so with the move we can draw something like this, like a rectangle, P1, P2, P3, P4, and then go back to P1. So this makes a triangle, rectangle in here, and then we go back to the prepared position above P1, which is P5. P5 is above P1. P5 in here. So with this simple move, we make a rectangle in here. And the second one would be the let's go to check the triangle first. So the triangle is also very similar to the rectangle. You can see here, we just go to P21. 21 is a point above P22. This is P21 above here, and then go down to P22, and then move to P23, and then move back to P24, and then move return to the home position of P22, and move up to P21. Okay, just to easy to understand, and I think this one as well. This is the circle command. So first we go to P17. 17 is a point above P18. This is P17. P17. Then we go to P18, go down to P18, and we use the command circle. Circle 3. We use circle 3 to go to like P19, P20. We move from the current position P18, and then we use these 3 points to go to with P19, P20 to make a circle, and then go back to go P18. This is the circle command, and the 1 here means it goes 1 time, 1 circle. Okay. Here's some videos for you to see how they move. Okay, first we are going to see the score here. This is the rectangle. You see, first P5, then go to P1, 2, 3, 4, 4 more commands. Okay. And then we go triangle. 21, 22, and then go in here. And then the circle, P18, P17 first, and then P18. So in this one, the parameter here is not one. There will be several repeats for this circle. So you can see it's moving around, round, again and again. So that's the difference for this complex motion. Okay. The next part will be the introduction of the end buttons operation. So this is a picture of the end buttons of CR robots. You can see we have this button zooming here. Actually, this photo is a very old one, and now we are changing the colors of these covers on the CR robots. The latest one should be light gray, and so you can see we have these different 5 buttons in here. The biggest one in the center is open or close handhold teach. When the robot is in enabled status, press and hold this button for 2 seconds. You will be ready. You will be able to move the robots freely with your hands. And also, the button on the left is the enable or disable button. So if the payload is configured rightly, you can press the button to enable or disable the robot. When the robot is enabled, you can do with the handhold teach function. Also for this trajectory record button as well. So once the robot is enabled, you can press and hold this button for 2 seconds, and it will start to record the trajectory. And when it's done, press it once, and the trajectory will be recorded. And this button is to playback. When the trajectory is recorded, press and hold this playback button for 2 seconds, and the robot will just repeat what you recorded just now. And the last button here is the control button for the end effectors. As I mentioned in the previous pages, once we configure rightly for the entors, the robot will be able to control the end effectors, such as some suction cups, some grabbers there, just to pick up something. We can control the grabbers with this button as well. Okay. Another thing is that we can see we have different lights. We have different lights in between the buttons. The lights between the buttons shows the status of the robot. Usually, when you just power on the robot, the lights should be green. Should be blue. Sorry, should be steady blue. And when enable, the lights will turn green. And in trajectory recording, the lights will turn yellow. And there will be a video later. I can show you how the trajectory is recorded. Okay, this is a video, and I can show you. Nope, it's not working. Let's see from here. You see, okay, let's watch the video first. Okay, so from the start, you can see that the lights of the robot is in green. Green means the robot is enabled, which means the powers are now in control of the robot. And in this way, we press the trajectory recording button, and the lights change into yellow. And now we're recording it. You see the moment here? The robot recorded it. Press the button again and press the playback button, and lights will be yellow running, yellow blinking. The robot just repeat what we recorded. Let's watch it again. Record and replay. Okay. This is the end button. Trajectory recording and playing. So you can see with this function, we don't need any computer. We don't need any tablets or smartphones. We can do it with touch of the end buttons. If configured rightly, we can also control the end users, the end effectors on here. Let's continue. So some users might ask, if I recorded some trajectory, how can I call it? How can I use this function in the script or in the blockly? So we developed this function here. We use this rev string. This is the name of the file we just recorded, and we can change it in the settings of the software, and then locate to this, and we start parse this one, and it will do the rest. It will just you can run the scripts to replay your recorded trajectory. Okay, let's check this video. So first, we are going to record the trajectory here. Now it's the same to record the trajectory with the buttons. And now we got this JSON file. You can see that this is the name. This is the name of the JSON file. And now we are running the script. You can see the indicators running, and the robot just moved what we recorded. And this is how we use it in the script. We can also do the same in the blockly. We have the block. We have in the latest version of Dobot Studio Pro. We have the block that is you can replay the recorded trajectory. Okay, let's watch it again. First, record it. Then run the script. And now we are running the trajectory. You can see that the trajectory is recorded with the same speed, same time you just recorded. And now it's repeating. Okay. All right. So that is the introduction about the trajectory recording, and now we go back to the next part. Is coordinates. So first one would be the base coordinates. The base coordinate is a coordinate system determined referring to the base of the robotic arm. So you can see here we have this XB, YB, ZB. This is the base coordinates. among which RXB, RYB, and RZB are the rotation angles of the tor center point TCP around the default base coordinate system X, Y, and Z axis, with the Y plus of the base coordinates is constant with the direction of the base loading ahead. Okay, so this is the base coordinate. And now this is the tor coordinate. The default tor coordinate is like this. The tor coordinate system is a coordinate system that defines the position of the TCP, which is the tor center point. Tor center point, which this is the TCP in the center of the flange. Okay. So its origin and direction are constantly changing with the position and angle of the indicators. The current system supports 10 up to 10 tor coordinate systems. Among them, the tor coordinate system 0 represents the default one, which is as shown in the picture. This is the default one. And you can, which is located at the end of the robotic arm. Without no tor installed and cannot be changed. But for the rest of 9, you can change them according to your real needs. And how do we create tor coordinates? In the 6-axis tor coordinate system, you can generate by 3. You can generate the tor coordinates by 3 points teaching methods like TCP and ZX. After installing the tor at the end of the robotic arm, adjust the position of it. And the TCP is aligned to the same point from the 3 different directions, like this. And then the tor position offset is obtained. Then obtain the tor posture offset according to the other 3 points, A, B, and C. And when establishing the tor coordinate system, please ensure that the reference is default tor coordinate system. This is how we establish the tor coordinates. And also here at the system, we can choose from the global coordinates. Users can custom the tor coordinates. There will be 9 tor coordinate systems can be defined by themselves. Users can switch the defined tor coordinate system in the jog interface. Just like this, we can choose the right one. We can create here and choose the right one if you want to use. And this is a user coordinate system. This is a user-defined working bench coordinate system or indictor coordinate system. Its direction of origin and each access can be determined by actual needs. It's convenient to target the position of each point of the working process and arrange tests. So how do we create user coordinates? Actually, those contents are okay. There are three different ways to do it. The first one is to use dots. We move the NTCP to any points A to determine the origin of the coordinate system and determine the user system direction according to the default tor coordinate system. And we use the line and here to make a straight line by any 2 points A and B. Determine the positive direction of y-axis following the direction from the point A to B. The positive direction of z-axis is determined by the zt-axis to the point A tor coordinate system onto the vertical plane of the straight line, and then determine the positive direction of x-axis according to the right-hand rule. And then the last one will be the plan. According to the 3 points teaching methods, mode the manipulator to any mode the robot to any 3 points A, B, and C. Among them, point A is the original, and connecting the line between point A, B determines the positive direction of x-axis of the user coordinate system. Point C makes a vertical line along the x-axis to determine the positive direction of y-axis and determines the direction of the z-axis according to the right-hand rule. So with the user coordinates, we can we can do like this. On plan 1, establish a user coordinates, use a 3-point method. On this plan, we establish a coordinate system, and then select several points and write a simple program on to run. Then we move the plan from A to B. We move plan from plan A to plan B, plan 1 to plan 2. And then on plan 2, establish user's coordinates user 2 with a 3-point method, and then change the user coordinates in the program from user 1 to user 2. And then when running the program, the tracks of the devices on the 2 plans are constant with each other. So in this way, we can run the same program. We don't have to set up the points again, just use the same coordinates, just using the different coordinates.